First question, sketch the graph of y mod 1 minus 6 into 2 minus 6 and y 2 times 1 minus 6 on the same plane and solve the inequality this, right? Okay. Right, first thing is this graph we have to sketch. Y equals modulus 1 minus 6 into 2 minus 6. Okay, first of all, we'll draw the graph without the modulus. Without this modulus, that graph I am going to draw first. Right here, when you multiply minus 6 plus 6 can come in, the graph of this is minimum graph. Two roots we can write. Equal this to 0, x equals 1. Equal this to 0, x equals 2. Roots are 1 and 2. Right, minimum graph, x at vertex. X at vertex. We can find adding these two roots and dividing by 2. We get 3 by 2. Y at vertex. Y at vertex can be found, people. Put this x at vertex 3 by 2 where here and here. 1 minus 1.5 means minus half. Right here. 1.5, 2 minus 1.5 means plus half. Here minus 1 over 4. Then the vertex 3 by 2 minus 1 over 4. Right. Then the graph we can sketch without the modulus. Without the modulus, the graph going to be this way. Roots are 1 and 2. This way. Y value at the vertex is minus 1 over 4. This midpoint is 3 by 2. You see, the graph is like this. This point is 2. When you put x equals 0 here, by 2. This is the graph. This is the graph without the modulus. In the modulus graph, what happens is, to get the modulus of this graph, the part that lies below the x-axis, that is this one, from here to this part. Keeping these two parts as the same, you have to take the image, mirror image of this part through the x-axis. Then that comes like this. That is the modulus graph is. Okay. Then I am going to draw that modulus graph here. This way we get it. This is right. This is 2, 1, 2, no. This 1. Then this is going to be plus 1 over 4. This point is 2. Right. This is the modulus graph. Right. Now, second graph, ask in row. Y equals 2 times 1 minus 6. When you remove the bracket, we get like this. When you put x equals 0, put x0 here, y2. The graph passes through 0, 2. Put y0. Y0 here. Take this side. 2x equals 2. 2x equals 2 means x equals 1. Correct, no? Then this graph passes through 0, 2 and 1, 0. 2 and 1, 0. This is the point x0, y2. x1, y0 is this point. That graph is this people. This is that graph passes. y equals 2 times 1 minus 6. Right. Then what is asking next? Asking to find the range this 1 minus 6 into 2 minus 6 modulus greater than 2 times 1 minus 6. Okay. That means this graph should be this graph. That means black graph is this. Black graph should be above the red one. Yeah, you can see in between 2 and 1 only, red is above the black. Left of this 0. Here, you can see here. Now really between this point and this point, only the black is below. Or in other words, red is above. Now asking here, black should be above the red. That happens on the left of this point. Black is above. And the right of this 1, black is above the red. So this happens in terms of x when you say left of 0, less than 0. Right of 1, greater than 1. That happens x less than 0. Here 0, no. X less than 0. And, right? X less than 0 and x less than 1. X less than 1, again, that is above the red. Solution. Right, second one. Number 2, we are given to solve this. Four to the power x squared plus 2 minus 9 into 2 to the power x squared plus 2 plus 8 equals 0. I can write this 2 to the power 2, this 4. I can write that x squared plus 2. This way I can write. Okay. Even I bring this power x squared plus 2 inside to this out. Like this. This way. Yeah? Then I take a substitution this way. Let u equals 2 to the power x squared plus 2. I take like this. 2 to the power x squared plus 2 I take as u. This on u. Then this reduces to what? U squared minus 9u plus 8 equals 0. Now you can factorize this. U squared plus 8 u squared minus 1. Not u squared, u minus 8. U minus 8, u minus 1. Then you get u equals 8 or u equals 1. There are two answers like that you get. But you know, u is this, no? 2 to the power x squared plus 1. Here I can write 2 to the power x squared plus 2 equals 8 or 2 to the power x squared plus 2 equals 1. Okay. Right. Now I can write next. The first one you can see this way, 2 to the power x squared plus 2 is equal to 8. You can write this as 2 to the power 3. Then the bases are equal, no? The powers you can equate. This gives us x squared plus 2 equals 3. X squared is 1. X is plus or equal to x equals plus or minus 1. So, secondly, we have this, no, 2 to the power x squared plus 2 is equal to 1. This 1 you can write 2 to the power 0. Right. Then you can equate again this. But this is impossible. Reason? X squared is always positive or 0. That plus 2 equals 0 never happens. This is always positive, impossible. Impossible, right? So therefore the solutions are x equals plus or minus 1. Two solutions. Other two solutions, huh? Right. Right. Next one, question number 3, limits question. Okay. Limits question given this way, limit 6.2 right, root 1 plus 2 plus x minus root 3 x minus 2. Right. X going to 2 square root 1 plus again root 2 plus 6 minus root 3 divided by x minus 2. Asking to find its limit. 1 over 8 root 3. Okay, now here first I am going to find people multiply this numerator and divided by the conjugate of this. Then what happens? This is what we get. 1 plus root 2 plus 6 minus root 3. No. This I multiply by its conjugate. Square root of 1 plus root 2 plus x plus root 3 divided by x minus 2 this way. Limit x going to 2. Here we can simplify. This is like a minus b into a plus b. No. Then square of this minus square of this is the answer. Then I am going to write that. Then the root this will eliminate. 1 plus this coming, no? Right? This root will eliminate. 1 plus root is minus root squared is minus. We get like this, huh? Then here we have x minus 2, 1 plus root 3. Now here we can simplify this. 1 minus 3 is minus 2, no? Then here really this is 2 plus x root minus 2 now. Then again I multiply numerator and denominator by the conjugate of this. Right? Limit x going to 2. 2 plus x root minus 2. Its conjugate going to be 2 plus x root plus 2. Then x minus 2 here, this part, and plus this, plus root 3, and this we have to write, multiply that, no? This way, right? Then again, this two product you can write square of this, the root will eliminate, square of this, 2 plus x minus 4. Here we have this. But people now here 2 minus 4 is minus 2, x minus 2 coming, no? Now this and this you can cancel down. Until cancellation of this x minus 2 with x minus the numerator, we don't put x2, right? That is the usual way of thinking here, right? Now put x2 for every x. Numerator 1 now. Here when you put 2 people, here we get 4. Square root of 4 is 2. That 2 and this one is 3. Square root 3. And here also square root 3. Again put when x2 here, 2 plus 2 is 4. Root 4 is 2. 2 plus 2. Then here 1 over 2 root 3, this is 4. 4 and 2, 8. 1 over 8 root 3. This is how we take the answer. The perpendicular drawn to the curve given by this at the point x equals 1 meets the x axis, right? Y equals x times x squared plus 1. Right. So then first we'll remove the bracket. X cube plus x. We'll find dy by dx. 3x squared plus 1. Now I am going to find dy by dx at x equals 1. We get 4. Put 1 here, 4. This is a gradient of the tangent line at x equals 1. So then the gradient of the perpendicular line, how to find? Take the reciprocal of this n multiplied by minus n. Gradient of perpendicular. What? Minus 1 over, right? Then we need to find the equation of the perpendicular at x equals 1. There we need at x equals 1 the y coordinate. For this, we can write at x equals 1, y can be found. Here put 1, 1 squared plus 1. Here we get 2, no? We get y2. Then we can write the equation of the perpendicular to the point at the point x1, y2, no? Point is 1, 2. And now roughly if we consider people this graph like this, suppose this is not the exact diagram of the graph, right? Suppose this is that graph. Suppose this is that point. This is the tangent. This is the perpendicular drawn. Right. Equation of this only now we need to find. This point is 1, 2. The gradient only just now we found as minus 104. Then using y minus y naught equals gradient times x minus x naught, you can find the equation of this perpendicular. Okay. Then we get y minus y naught is 2, gradient is minus 104, x minus x naught is 1. Right. We need to find the coordinates where applicable. Find the coordinates of the point, the perpendicular drawn to the curve given by this at the point x equals 1 meets the x-axis. Meets the x-axis right here. This point only asks meets the x-axis, right? This is x-axis, no? Y-axis. This point only asking. People, at that point, you know y 0. When put y 0, put y 0, then find x. Then you can put y 0 minus 2, we get minus 8. There, minus 6 plus 1. Then this side, 9. Then this point has the coordinate, x coordinate 9, y coordinate 0. Therefore, the point is 9, 0. Point is 9, 0, no? Right. Number 5. Number 5 given this way. 2 tan inverse 6 plus tan inverse y equals pi by 2. We'll take this angle as alpha. This as beta. Then we get tan alpha what? X. Tan beta y. Then this equation becomes 2 alpha plus beta equals pi by 2. 2 alpha plus beta equals pi by 2. Right. Now, we'll take this 2 alpha left hand side, take this right hand side, pi by 2 minus beta. Then you can take both sides. Tan 2 alpha equals tan pi by 2 minus beta. Tan 90 minus beta is equal to cot beta, no? This is cot beta. Tan 2 alpha is equal to cot beta. Right, you know, tan 2 alpha we can write as 2 tan alpha divided by 1 minus tan squared alpha, right? 2 tan alpha divided by 1 minus tan squared alpha. Cot beta you can write as 1 over tan beta. Now we can substitute for tan alpha and tan beta and simplify. You get this answer. Okay, our tan alpha is x. Then 2x we get 1 minus x squared is equal to 1 over tan beta. Tan beta is y, 1 over y. Right, we'll use the cross multiplication, 2xy, 1 minus x squared, take this side, 2xy equals 1, no? Now we'll add to both sides y squared. Squared plus 2xy plus y squared equals 1 plus y squared. I added to both sides y squared, right? Now the left hand side going to be x plus y perfect squared, right hand side 1 plus y squared. That we get. Number 6 next. Sixth one, now. To smooth the small spheres A and B of same radii but masses 2m and m respectively move to each other with same velocity u and collide directly. If the coefficient of restriction is E, find the velocity of A and B after the collision. Right. This way we have that. AB 2m m. This way it's u. This way it's u. After collision, we take the velocities AB 2m m v1 v2. Right, now we can apply first conservation of linear momentum rightward 2m v1 m v2, the total momentum after impact. Before impact it is 2mu rightward minus mu leftward. M you can cancel down. 2v1 plus v2 equals u, number 1. Now we can apply Newton's law of restitution also to rightward direction. That is minus c times relative velocity before impact. Before impact, I stop B, given this u right, this u right. Then V will be at rest. This will get u and another u to u. After impact also, I stop B, apply V2 on B left, A also apply V2 left. V will be at rest, A will have rightward V1, leftward V2, then A will have rightward V1 minus V2 to certain velocity. Then this is the left hand side. Then that comes as minus 2EU, number 2. Okay. By solving this 1 and 2 people, you can take 1 plus 2, right, will give us the value of V1. V1 comes as u by 3, 1 minus 2e. And solving this, we can take V2, u by 3, 1 plus 4e. This you get the two velocities. Now next one asking what? Show that if E equals half, the sphere A comes to rest and loss of kinetic energy of the collision is mu squared. A, after impact, A has the velocity V1. V1 is given by this. If E is half, what can you say? If E equals half, you can say people put half here. 2 into half 1, 1 minus 1 0, V1 0. Then A comes to rest after impact. Understood? Right. Then E equals half, I am going to find V2. Then V2. What is V2? U by 3, 1 plus 4E. E is half. Then here we get 2. Then we get V2 as U. Right. Then people, loss of energy. Asking loss of kinetic energy. Loss of kinetic energy equals, how to find that loss? Loss is found initial minus final. Initial kinetic energy half 2m u squared plus half mu squared. After the impact, now A is at rest, B moves with velocity u. Its mass is m. Then its kinetic energy half mu squared. After impact, the available kinetic energy, we have to subtract to find the loss. Loss is found initial minus final. Then this 2 you can cancel down. This and this you can cancel down. Then loss of kinetic energy comes as mu squared. Right. Number 7. Projectile question, no? Okay, number 7. Particle is projected from a point O on the ground. Making an angle pi by 4 with the horizontal. Passes through the top of a vertical pole of height a by 4 at a distance simply from O. Show that the maximum height the particle rises is a by 3. This way. A by 4. This is 3. Right. Now we can apply S equals ut rightward for this motion. Horizontal displacement is A. Velocity is u cos pi by 4. I take the velocity of projection as u. U cos pi by 4. Right? Into t. Then cos pi by 4 is 1 over root 2, no? Root 2 a divided by u is the t. Now for this motion from here to here, again I apply for the particle S equals ut plus half a squared. We apply upwards. Right? It moves a by 4, no? Height a by 4. This u sine pi by 4 into time t minus half dt squared. Okay. U sine pi by 4 is 1 over root 2 t is answer. Root 2a over u. G by 2 t squared. T squared going to be 2a squared over u squared. This and this you can cancel down. Then bring this a to this side. Minus 3a over 4 come in. Right hand side. These two you can cancel down. G a squared over u squared coming. This a you can cancel down. Minus also we can cancel down. 3 over 4 is equal to Ga over u squared. Right? Then you can take u squared subject and 4 Ga by 3, and therefore we can write u. U equals to root Ga by 3 is u. Now ask the maximum height, no? Now we apply for the motion. People at the maximum height, the vertical velocity component is 0. Then vertically upwards direction we apply to find the maximum height. V squared equals u squared plus 2as. Right? Now apply here. V squared equals U squared plus 2as. Now applying V squared equals U squared plus 2as upwards. At the maximum height, V squared 0. U means U sine 45, no? So cos 45. U sine 45 perfect squared minus 2g maximum height suppose h. Bring that to this side. 2gh. U squared sine 45 is 1 over root 2. Its perfect square is 2. Substitute for U squared 4ga by 3. 2gh half U squared is 4ga by 3. Right, people? This 2 we can here bring here 4. That 4 and this 4 we can cancel down. That means this 3 you can cancel down. G and G can be cancelled down. H equals A by 3. You can take it like that. Huh? Number 8. Circular motion part. The particle P of mass lambda m is suspended from a point O by a light inextensible string of length simple A as shown in the diagram. When the particle P is at equilibrium, a particle Q of mass simple m moving horizontally with velocity v directly collides with P and coalesces. If the combined particle just reaches the ceiling, show that answer of V is this, right? You can take it like this. Here, suspended from point O. This particle is lambda m. Other particle come in with velocity v. Its mass is m. This is P, this is Q. Right now, thereafter, these two particles together move. Right? Now, we can apply here conservation of linear momentum for the collision. Right? After impact, the total mass lambda m plus m. Suppose after impact the velocity is w. This is the momentum after impact of the combined object. Before collision, mv is the momentum. M you can cancel down. W you can subject. V over 1 plus lambda is the velocity of the combined particle after impact. Now this combined particle begin to move in a vertical circular motion like this. Initially with the velocity w, it moves like this along a circle. Here. Right, we are given that reaches to the same horizontal level, that just reaches the horizontal level of O. That means once the combined particle reaches to the level of O, its final velocity is going to be 0. Here, its velocity is 0. Right. Now, we can apply here conservation of mechanical energy. Here, total kinetic plus potential energy should be equal to, at that point, total kinetic and potential energy. Right. And then we can take that answer by applying conservation of mechanical energy. Okay. I am going to take their people as the potential energy 0 level this. Then once the particle reaches this position, no velocity, therefore no kinetic energy. no potential energy. Here the total energy is 0. Should be equal to here total kinetic plus potential. That means mechanical energy. What is that? Half mass is m times 1 plus lambda. Velocity is w squared. Half m v squared. No. And people, their potential energy minus m 1 plus lambda is total mass. G, h is a. A is the length of the string. Should be equal to 0. Then this m times 1 plus lambda, you can cancel down. Then Ga, you can bring to right. Here we get w squared by 2. Okay, then we can take this here. Then we substitute w squared. It is v squared over 1 plus lambda perfect squared. Here now 2Ga. We get v squared equals 1 plus lambda perfect squared 2Ga. V equals 1 plus lambda root 2Ga. Right? Okay. 9. The question vectors of 2 points A and B related to an origin O are given by I minus 2J and minus 2I minus 2J respectively. Right. C is a point on AB such that AC-CB ratio K is to 1 minus K. K is a positive. So that AC vector or C vector asking, no? X unit vector I, Y unit vector J. Your position vector of A, I minus 2J. Position vector of B, minus 2I minus 2J. Between A and B, we have a point C, like this point C. The ratio here K, this is 1 minus K. Asking to find OC vector, that means position vector of C. For C vector, we can write, people, or to C vector, we can write O A plus AC. Right. O A plus AC vector, this no, that you can write as a fraction of AB vector. Right. AB vector, we first divide into this plus this. 1 minus K plus K is 1. And take K times of that. Then we can write as KAB. Correct, no? Right. Now, I can substitute for OA vector I minus 2J K times AB vector mean B vector, position vector of B minus position vector of A. Position vector of B is this minus 2Y minus 2J. Position vector of A, I minus 2J minus I plus 2J. Right? Now we can simplify it. OC vector I minus 2j plus k times, right, here within bracket we can write minus 2i minus I minus 3i, okay, minus 2j plus 2j we can cancel down. Then we can write OC vector, take these items together, we have 1, they are minus 3 I minus 2j. This is the OC vector first answer, no? Now OC and AB are perpendicular. Then show that k equals 1/3. OC AB perpendicular. When OC AB perpendicular, people, then OC dot AB should be equal to 0. OC and AB perpendicular means OC dot AB should be equal to 0. Right now, OC vector here we just now found 1 minus 3k I minus 2j dot AB. AB means, right, this vector, A to B vector. That means minus 3i here should be equal to 0. Correct, no? Minus 3i only we got for this AB. Right, you know here how to take the dot product. I coefficients we have to multiply. Minus 3, 1 minus 3k should be 0. For this to be 0, this must be 0. K equals 1/3. K equals 1/3. The last part, question number 10. Right. It is a uniform rod AB of weight simple W and length 2a is smoothly hinged at capital A. The rod is kept in equilibrium with B below A, making an angle pi by 4 with the vertical by a horizontal force P acting at B as shown in the diagram. So that the reaction at A inclined tan inverse to the horizontal and find the reaction at A and the value P. This is that, no? Right. You see horizontal force P given here B. Uniform rod weight W. Right. Then I can produce the line of action of P like this, line action of weight like this, line of action of weight like this. This rod is in equilibrium under the action of three forces, people. Huh? One is P, other one is W, other one is the reaction at A. You know, whenever any object is in equilibrium under the action of three forces, the three forces must meet at a point. So therefore, the reaction at A should definitely pass to the point this, like this. Huh? This is the reaction at A. Suppose R. They must meet at a point. Right. This angle given as pi by 4. This is A, this is A. Uniform rod, center of gravity at the midpoint. Let this angle be theta. Okay. I'm asking to find this theta. Right. We can make a construction here by using geometry. You can take this answer. We'll drop a perpendicular here. Right. Then this height you can write. Right. That's going to be right 2a here This is 2a. This is pi by 4. 2a sine pi by 4. And this length also we can write. That length means this length. A cos pi by 4. A cos pi by 4. Then you can write tan theta. How to write tan theta? Tan theta by this triangle, opposite side divided by adjacent side. 2a sin pi by 4 divided by a cos pi by 4. You know sin pi by 4, cos pi by 4 equal. We can cancel down. A and A you can cancel down. Tan theta is 2. Theta equals tan inverse 2. Okay. Theta equals tan inverse 2. Now we are asking to find that R and P. That can be found by resolving forces horizontally and vertically. For the equilibrium of the rod, we can resolve the forces vertically upwards. Then this is the R sin theta, upward component acting on the rod as the upward force. Downward force is W. Then R sin theta equals W. Then R can be found W over sin theta. People, for this tan theta 2, we can draw a triangle like this. Tan theta 2 means 2 over 1, no? Tan means opposite by adjacent. Opposite to adjacent 1. Then the hypotenuse is going to be 2 squared plus 1 squared root. 2 squared is 4. 4 plus 1, 5, root 5. Then you can write sin theta. What is sin theta? Sin theta opposite by 2 by root 5 cos theta adjacent by hypotenuse 1 over root 5. Right. Then substitute here W sin theta 2 over root 5. Then we get root 5 by 2 like this. Correct, no? Sin theta 2 over root 5. Root 5 goes down. And P, resolving horizontally, you can write R cos theta equals P. Then P equals R cos theta. R means W root 5 by 2 is the R, is cos theta 1 over root 5. Cancelling this 2, we get P as W by 2. Okay, right. This way we can take those answers.